You got my people. Oh. And also this. Hey. I swallowed the biscuits. Give me. Sham sham. Sharing is caring. Here you go. Oh no. Okay. What's a square? No. No squares. The last square and I'm eating.
Alright guys, we're gonna be online soon, okay?
Triangle.
We're online.
So please. Yeah. We have them at home.
What do you have at home?
We have these bits.
Oh, do you like them?
Yeah.
Mm.
This is the last square biscuit in the house. In the whole house. And I'm eating it. Why are you eating in front of us? Really slowly. NPC. I'm an NPC.
Alright guys, come on, it's almost 4:30. Have a look at this problem. How would you start doing this problem? Think about it.
We take a weight. And then. Wow, this raspberry is white absorbs most color, so it becomes like very soft.
Oh guys. What are you thinking about when you look at this question?
These are the same.
Yeah, we are. Focus on this. Oh.
and he put all 11 on one side with a random except even when it's even. And then put one on the first one. If he puts 11 weight on the first one and one way on the other side, and so it will be correct. And then and then he takes that one off, and then puts the other one onto the 11, so it becomes 12, and he.
Wait, how does it help to weigh the 11 against 1? Because if you do 11 against 1, you know it's heavier, right?
Yeah.
And if it's heavier, it's going to show the correct weight. So you can't find out anything about the weights or the coin, or the balance. Yeah, so I think a common mistake when you're doing this kind of problem is you try to do all of it in one go, okay? So if you want to try to solve this problem, I think it's best to start with an easier version of the problem to understand the problem more. That makes sense? So instead of doing 13 weights and one of them's fake, yeah, you can try 3 weights, yeah? 3 weights and one of them's fake, and you don't know which one's the balance. Yeah, that works. Understand? Michelle, do you understand the question?
No.
Okay.
I can't really understand.
So if you don't understand the question, why are you just sitting there? You're not even thinking about it. So how will you ever understand the question? So basically, there's 13 weights, okay?
Yeah.
12 of them are real,
Yeah.
and they weigh the same, but one of them's fake and weighs more than the others, yeah? Right?
Yeah.
And you got 2 weighing machines, like 2 balances, yeah? One of them's good, normal, and the other one's fake, okay? So both the normal and the fake one, they show the correct result if the balance is unequal, yeah? But if the balance is equal, the fake balance could show the wrong result, okay? So it could show either the right or the wrong result, yeah? Okay, it could show any of the results randomly. And the question is, can you determine which weight is the fake one after 3 weighings, right? So you don't have to do the problem they give you right away. You can do, is it possible to weigh one time, yeah, and to figure out if if there's only 3 weights altogether instead of 13, yeah? That's much simpler, right? There's only 3, yeah? If there's only 3 and one of them's fake, could you figure out which one's fake using just one weighing?
Wait, but the wrong one, even if they're both the same thing, like they're both real, will they equal the something different?
Yeah, the balance, if you use the wrong balance, it could tell you it weighs different even though they're the same, yeah?
Yeah.
That makes sense? So try to do it for a smaller number. So 3 weights instead of 13, okay? And I'll show you the answer to that in a bit. But I want you to try it. We still got quite I don't think you do. What's your answer?
So first, you get like 2 weights, and then get one of the balances, and you balance, and if one of them are heavier, it could be the weight that's stake, or it's the balance that's stake. And then you put, then you get another 2, and if the other one is still above, then you know that balance is the fake one. Then you use the last balance with the last turn, and then you do it.
You didn't explain it properly, okay? So you only said if they were different. What if they were the same? You know? You should think about it and write it down on your paper. The fact that you came up with it so quickly makes me kind of suspect you're wrong, okay?
Hey, what if you bring 2 real ones and then and it ends up being on the fake layer?
Yeah, if it's on the fake balance and you have 2 real ones, one on each side, it could tell you that they're different. Or it could tell you they're the same.
But if you put a fake and a real one on the fake layer, then it's possible that they'll be equal. But you don't know which one's which. So.
No. You gotta read the question, okay? Is that what Ernest looks like? Up close. That's very weird. That's a very slow entrance. Creaking for 20 seconds. How are you, Ernest?
Hi.
Have a seat. Sit down.
Is Nathan coming today?
I don't think so.
What about Winston?
Winston, yeah.
I only know how to get 3, how to know which one's fake with 3 and 2 goes.
And 2 goes. Okay, I like that. Yeah.
Piece is fake and one is
Okay, so let me see.
distinction.
Look after it.
Middle primary.
Okay, so you got like 3 weights, right? Yeah?
Yeah.
Like, and you have 1 weighing, right?
Yeah.
Okay, so if you only have 1 weighing, it's kind of pointless to do like 2 versus 1, right?
Yeah.
Okay.
13.
Yeah, and if you got 1 weighing, you don't actually know what the balance is you're going to use, yeah? So, you would do 1 versus 1, right? Yeah?
Yeah.
And then you have to figure out what happens with all the possible outcomes, yeah? Okay. So, if it's equal, right? So if it says equal,
Then those are all those who go through. No, but it could be a fake. Wait. Could be the fake. So it could be the fake examiner.
Yeah, so
1 versus 1, if they're equal, then they're both real. Because the fake one weighs more than the other one.
No, but what the fake weight is.
Oh, the fake weight.
yeah, so the balance could be fake. Yeah. Okay, but still, I mean, look, if the balance is real, right? Yeah.
Yeah.
So if the balance is real,
They're both real.
if the balance is real, let's just say BR, right? Then we have real versus real, right? Yeah. And then you figured out the other one's fake. Yeah.
Yeah.
Okay. What if the balance is fake?
What the 12 one? What if you put on the real scale
If
you
the
just put
balance-
6 on each
If the
side?
balance is fake,
Hmm.
then it's real
Yeah.
versus fake.
We're talking about this three of them, yeah.
If
So
the
actually,
balance-
this is the same even when in the 12 case, right? Because you still could weigh 1 against 1, yeah. So what if the balance was fake?
If it was fake, then it would be real versus fake.
Why would it be real versus fake?
Fake balance doesn't show the actual thing, so the fake balance might show it as
No. So you gotta
if
read the
it's
question,
equal,
okay?
then one is fake and one's real. But if it's not equal, that means they're both real.
So the fake one could show the right result, okay? But it doesn't have to, yeah? You gotta read the rules, okay?
Random result on the website.
oh.
Wait,
So
so if they're
every-
equal, then they'll still be equal. It could still be
So it
equal.
could either be real
Yeah.
versus real or real versus fake.
If
Yeah,
it's
but
equal.
we're not saying they are equal, yeah?
Yeah.
We're saying the balance shows that they're equal, okay?
Then
Just focus only on this, okay?
then if it's the fake one and it shows that they're equal, then it could be any possibility. If it's the fake balance.
Are you sure about that?
It could be real versus real or real
Or
versus
a
fake.
high chance.
But can it be?
Mhm.
Can it be real versus fake? Huh? No, you gotta actually think about it. Just read the rules. It tells you what the balance does.
So when they're equal, just a random result, it could show equal. With a different correct
Oh.
result on the weights.
When weights are random, so
Yeah, the
Oh.
fake balance is only fake when the things are equal, right? Does that make sense?
Yeah.
So the only way for this result to not be true, yeah,
yeah.
is if they were equal, right? Because the fake one could only show wrong results if it's equal, yeah?
Yeah.
But if they are equal, then showing it's equal is correct, right? That makes sense? So it can't be fake and real, yeah?
Yeah.
It has to also be real and real. Does that make sense?
Yeah.
Because if it was fake and real, right, the fake balance would show the correct result. It says that, right? Do you understand?
Yeah.
See, one shows correctly which pan is heavier or that their weights are equal. The other only gives the correct result when the weights are on the pans differ. Yeah. So if the weights are different, it would show they're different. Yeah. But that says they're equal, right? So they actually have to be equal. Yeah. So you actually worked out something very useful for the whole problem, is that if either of the balances show the weights are equal, the weights are actually equal. Yeah? It's only when it shows the weights are different, you might have to worry about the balance being fake.
Yeah.
Does that make sense?
But
Okay.
what if they weren't?
Yeah, if they weren't equal, the balance would show exactly which one's heavier, right? Read it. Yeah?
So then,
The other one gives the correct result when the weights on the pans differ
So
and
if
gives
it
a
is
random result
on the weights,
when the weights are equal. Yeah? Okay. So if the weights differed, it would tell you that they differed. Yeah?
yeah.
So if it's telling you the weights are equal, then you know that the weights don't differ and therefore they're equal.
yeah.
Yes?
Mm.
Okay, good.
So if any of them so if it's different for any chance, no, if it ever differs, then we know one of those is the fake one.
What do you mean if it ever differs? If the balance ever shows it
Like if the
differs?
balance ever shows that they're different, then you found the faulty one.
No, no,
Fake
no,
one.
no, definitely not.
No, like the fake piece.
No, it could be the fake balance. You know, you could have two real pieces, and the fake balance could tell you that they're different.
Oh yeah.
Okay. Yeah. So that's the opposite direction.
Okay.
You know.
So if we can solve the 3 one, I'm pretty sure we can solve the 12. Because if you put the 12 into half and the heavier one, so you could turn it. So the heavier one, you could. So the heavier 6, you could split it up to 3s. And the heavier 3, you could put it into. So how we solve the.
We haven't solved the 3 yet. Yeah. Okay. I just said what happens if it's equal. Yeah. What happens if it's not equal? What happens if one of them is greater than another one? What
That
happens?
means
What happens if one of them's greater?
either one of them is different or they're equal. For the for the real one, then it would show. Wait, for the real one, then it would show the difference. For the fake one, it would show the difference, or if they were equal, then it would show a difference.
The real one, it would show a difference.
Yeah,
What are we talking about?
like the one that actually the one that the weight that the balance that is real will show that they're different, and the heavier one will be the correct fake piece.
The fake piece.
But
Yeah.
if it's the fake pan,
Yeah.
then who knows? Like
Yeah. So
then it could be.
Because you don't know which one's correct.
Yeah, exactly. So if it's the real pan, yeah,
And you found it, but if
it
it's,
could be fake greater
don't
than real, yeah.
yeah, we don't know which one's
Okay.
fake and which one's
But
real.
the problem is you don't know which weight you use, what pan you use, right?
Yeah.
So your balance could be fake, and they could both be real, and it would still show that, yeah.
Yeah.
So that means it's impossible to do it in one go. Can you see that? Because you could have a fake and a real, right? And you put it on the real balance, it'll give you that result. So then you take the heavier one, okay?
Mm.
But if you were to do that with the other balance and they were both real and you took the heavier one, you'd be wrong, right? Yes?
Yeah.
Okay. So that means you can't do it in one go, okay? Can you do it in 2 goes? This is what Gabriel was saying.
I don't think so, unless you're like really lucky.
Unless you're really lucky.
Yeah.
Why?
You can use if if they're not equal and you're using the fake balance, you can just use the other balance to see if it's really correct or not.
But why is that lucky? Okay, so I'll give you a few minutes to tell me to think about why you can solve this with two weighings, okay? So if you're allowed to weigh again, okay, why is it that you can solve this problem? Okay. So at the moment we just showed it's impossible to do it in one weighing, right? But the question is, can you do it in two weighings?
So if it no, no.
Like, what difference does it make if you can use two weighings, right?
You can make it with two weighings as long as no. Wait, never mind.
Huh? There's a bug. Michael's taking a while. What's he doing?
Maybe he's pooping.
Yeah. Alright, Michael's back, so I'm gonna explain. You guys know why you can do it in 2? So basically, the reason you can do it in 2, right, is you get to use both scales, yeah? So that's the only other thing you can do, right? If you just weigh it again the same way, you just wasted your second weighing, right?
Yeah.
So you have to do something other than what you already did, yeah?
Can use the same one with the other way.
Yeah, and you can assume, okay, that the weights are, like the way, the balance shows that they're different, okay? Michelle, you're not even listening to me, okay? No, no, no. It's not, you're not even listening to me. It's not, oh yeah, I'm not listening to you. No, you listen, okay? So, the balance, Michelle, you're still not listening to me.
If it's equal,
Put your pen away.
If it's equal, you can just weigh other ones instead.
Yeah, I mean, if it's equal, then we're done with the one weighing, right?
Yeah.
So you can assume both weighings tell you that they're not equal. Right?
The
Yeah.
thing is, you have 13. So what if you spend all 3 and all of them are equal?
I'm not talking about 13, yeah?
Okay.
So you still haven't done this. Just try to focus on one thing, okay?
Okay.
So you weigh with both balances, and they both tell you it's not equal, yeah?
Okay.
So there's 2 possibilities. Well, how many possibilities are there?
There only are 2 possibilities.
Alright, if you finish with it, put it in the bin.
There only are 2 possible possibilities. Both real or one fake, one real. And it uses both.
No, I'm talking about what the balance shows, yeah?
Yeah.
So the balance could show this one is heavier than this one, right?
Yeah.
On both of them, or it could just show it on one of them, yeah? What would it show? What would it show the other one then? What would it show on the other one?
That one's the big one and the other one's different than if it showed that one. So tried it on the other one. And if it still says that that one's heavier.
So the fake. So one of the balances could show that 1 is bigger than 2, right?
Yeah.
Like if this is 1, and if this is 2, yeah. The first balance could show 1 is bigger than 2, yeah.
Yeah. Yeah.
The second balance could also show 1 is bigger than 2, yeah.
Yeah.
But what if the second balance shows 2 is greater than 1, yeah?
Then that means they're equal. Right.
Yeah, you're on the right track, I think.
If the first one is real, then the second one. If the first one's real and the second one's fake, then they're both real.
What did you say?
If the first weighing you use the real one,
Balance.
the real balance, and for the second one you use the fake balance,
Yeah.
then that means they're both real.
No.
Hmm?
Alright, so obviously they can't both be real, right? Yeah. So what Ernest is saying is actually right, but he just stopped too early. Yeah.
Okay.
Because they can't be real, because if they were real, the real balance would have showed they were equal, right?
Oh yeah.
Okay? So the point is, one of the balances is real, yeah?
Yeah.
So if both balances show they're different, right, then the two weights have to be different. Does that make sense?
Yeah.
Because one of them is real, yeah? And both are showing they're different. Okay? So actually, but if they're different, what happens if they're different though? What happens if the weights are different? What does the balance show?
One's different. One's real. One's equal and one's not equal. Then it could mean that they're both real because
We're back at this again.
wait, let me check the other possibility.
So remember, we know they're different, yeah?
Yeah.
Because both weights, both scales show they're different, yeah? And one of the scales is correct, yeah?
Yeah.
So that means they're different, yeah?
Yeah. But
Okay,
which
so
one is-
now you assume they're different, yeah?
Yeah.
What would the scales show if they're different? How do the scales work?
If one's fake and one's real, then they would both show the same thing.
Yeah, they'll both show the same thing, right? Because they'll both show the true thing, yeah? Because both of them are essentially real scales when the things you put on are different, right? Yeah? So it's actually impossible to have one is greater than two on one of them and two is greater than one on the other one. Yeah?
Oh, yeah.
Right? Because they both would have to show one is greater than two. Yeah?
Yeah.
Or two is greater than one. Because they would both be showing the truth. Yeah?
And then you could also, and then you would know which one's heavy and which one would be lighter.
Hello? Level 14? Alright. Does that make sense? And so if they both show one is greater than two, then one is greater than two. Yeah?
Yeah.
And if one is greater than two, which one's the fake one?
One.
One. And you're done, right? Okay. Well, you don't have to apply this to 12 or 13, so you got to be patient. So you could. So at the moment, yeah, you got 12 and 13 and 3 weights, right?
Yeah.
We've got 2 and 3 and 2 weights, yeah? So can you see, like, we're trying to meet the problem somewhere, right? We don't have to go to 13 straight away. We could go like something smaller as well, right? We could do like 4, yeah? Or 5, yeah? There's no hurry for us to solve the question, you understand? Actually, the questions we made for ourselves are pretty fun as well, right?
Yeah.
Yeah. So, but that's the thing with maths. Okay, so you do this kind of thing until you reach the full question. Yeah.
Yeah.
It could take very quickly, or it could take forever. Yeah. But the
Yeah.
point is, you're making progress. What are you doing? Can you sit down? Make some room, Michael.
Oh, yeah, so.
You have a heated seat here. It's that room surface. Question 5. Alright, so let's summarize for Hillary what we have so far for question 5, yeah? So, we've changed the problem to something that we can solve, okay? So we changed the problem, instead of 13 and 12 of them are real, okay? We now replace the problem with 3 weights, okay? 3 weights, 2 of them are real, 1 of them's fake, yeah? The real ones weigh the same, but the fake one weighs more, okay? And then there's another tricky part of this problem is you have a balance which helps you determine what weighs more and what weighs less, okay? You have 2 balances. One of them's a real balance, which tells you the correct results when you put the things on the balance. And you have a fake balance, which tells you the correct results when the weights you put on them are different, okay? But it tells you it could tell you the incorrect result if you put the weights the same, that they weigh the same, okay? And yeah, and so we're trying to show that you can figure out which weight is fake using 2 weighings, okay? So how do you weigh them? Well, if you have 3 weights, there's not really any point weighing 2 against 1, okay? Because you don't really even know the difference between the weights. So it really only helps to weigh 1 against 1, okay? If you weigh 1 against 1, the thing that we discovered was that if the result is that they're equal, okay, and we don't actually know which balance we used, okay, could be the fake one or it could be the real one, yeah, but we realized that if the result shows that they're equal, okay, then no matter which balance you use, the weights are actually equal, okay, because if you use the real balance, okay, then obviously showing you it's equal means that the weights are equal, right? But if you use the fake balance, okay, the thing is, if you put different weights on the fake balance would still show you that they're different, right? Because the fake balance is correct when you put different weights on. Yeah. Okay, so the fact that it's showing you they're equal means that they can't be different, okay? And so therefore they're actually equal. So the point is, no matter which balance you use and you put 1 versus 1 and they're equal, they're actually equal. And if they're actually equal, they're both real, and the fake one's the one you didn't measure. Okay. So if you weigh them, you can assume that the result is they're not equal, because if it's equal, you know what to do. Okay. And how would you make use of 2 weighings? Well, you do it on each balance. Okay. And you can assume both balances show you they're not equal. Okay. Because if one of them showed you they were equal, then they actually would have to be equal, the weights, okay? So you can assume they both show you they're not equal, But if they both show you they're not equal, and one of the balances is real, then the weights are not actually equal. They're actually not equal. Does that make sense? So, and if the weights are actually not equal, then both balances are essentially the real balance, because both balances show the correct results when the weights are not equal. Okay? So then whatever the result is, the heavier one is the fake one, and then you're finished. Okay? So we managed to solve the problem when there's 3 fake weights, and 3 weights, and 2 of them are real and 1 of them is fake. Okay? So I would be happy if you guys can help me solve it. But when there's four weights, yeah? Yeah? So notice the things that we got from that was actually useful for the whole problem, because we actually figured out any time that the weight balance shows they're equal, then it's actually the correct result. Okay, that applies in general.
Is it still 2 ways?
So now we don't know, okay, but let's see if we can do it in 2 ways. Okay? But presumably you can do it in 3 ways, because you can do the whole problem with more weights in 3 ways. So now we have 4 weights, okay? Where's Lucas?
It is possible to do 4 in 3 ways.
To do 4 in 3 ways. Yeah, I guess the good thing about having 4 is you need to you might want to consider 2 versus 2, right? And if you consider 2 versus 2, the same results and conclusions you have will apply to 13
Or
weights.
you go 6 and 6?
6 and 6, is a little bit extreme. So
But if 6 and 6 are equal, then that would be too easy.
yeah. So if 6 and 6, you would assume they're not equal. But then if they're not equal, what could you get from that?
4.
Well, like, that's basically just saying one isn't.
Hmm.
Or we're just, like just one eliminated.
Oh yeah, you get to choose which balance you use. Yeah. So, but you can only use one balance at a time.
Even, it's still pretty random, because, like, you don't know which one's which and which one's fake and which one's real.
Hmm. Yeah. I guess if you use one of the balances and you got lucky that the balance was good and you could trust it and it told you it was different, then I guess you would narrow it down to 6 coins and 1 fake, right? And then you'd only have 2 ways. Yeah. So for your strategy to work, you might want to solve the 6 weight problem with 2 ways. Yeah. which is just 2 more than our 4-weight problem.
With the 4-weight problem, you can measure one-on-one first. If they're equal, then that means they're both real. And then you can measure the other ones, and then using 1 or 2, using the strategy before. If they're different, then you can use the strategy before without
Wait, you're saying 2 versus 2 first? What's your first
do
weight?
1 versus 1 first.
Okay, you do 1 versus 1 first. So, yeah, let's call the coins 1 versus 1. Okay.
If they're equal, then we measure 3 and 4.
Okay, if they're equal, then they're both real, yeah.
Yeah. So,
And
and
then
then
you
we
do
measure 3 and 4 instead.
3 versus 4. So then you'll have to get 3 is greater than 4, yeah.
Or 4 is greater than 3, but that doesn't really matter. And then use the other scale for 3 and 4. And use the same strategy we used last time for the 3 weights and 1 fake.
Yeah. Okay. So do you see what he did? So he got in 3 weights, right?
Yeah.
So if it's equal,
3 weights maximum though.
yeah. But can you see? You don't actually need all 3 weights, right?
Yeah.
See, because if they're equal, yeah, then you know that these two are real, right?
Yeah. Oh, that's Winston.
So Winston, double 14.
It's 10. Oh, that's
Yeah. So the point is, if those two are real, right? Yeah. Then the other two has to be one of them's fake, right?
Yeah.
And if one of them's fake, then the scale would always be correct, right? Because they're different. Yeah. So you wouldn't have to worry about which scale it is. Yeah.
Yeah.
It would be the real scale as far as you're concerned, right?
Oh yeah.
So
2
you'd already
maximum.
know that 3 is fake after 2 weights. Okay.
So for 4, it also uses 2 weights.
Okay. Then what happens if 1 is greater than 2?
If 1 is greater than 2, then we can use the strategy we used last time. Wait. Yeah. By using the other scale for 1 and 2.
Yeah. Right, give me one second.
You arrived just when he went to that room.
Winston, welcome.
So you can always do it in 2 moves.
Did you get a chance to look at the questions from last week? That's here for no reason.
You can do 4 and 2.
I can.
If you go for the first try that one's heavier, then you can use the strategy you used last time, which makes 2. If 1 is equal to 2, then you can measure 3 and 4, but then you know one of them is fake. And so that means they'll show the correct because they can't be equal. So therefore, and then you can, and because one's heavier, you can just choose the heavier one as the fake one.
Alright, hold on. So we're doing 1 versus 1, yeah?
1 versus 2.
Yeah, I'll catch Winston up in a sec. So, if we do 1 versus 2, and what says 1 is greater than 2, yeah?
Yeah.
What's your next weighing? 3 and 4?
No, still 1 and 2.
Still
but with
1
the
and 2.
other way. With the other
scale.
Yeah, with the other scale.
Okay, and then on the other scale, it says, yeah, okay. So you can't do it in 2 for your thing. So let's say the other scale says they're equal, yeah?
Oh. If 1 equals 2, that means they're equal.
Yeah. Then they are equal, right?
Oh, and then you have to measure the other 2.
Yeah, but then you know which scale is real, so.
Yeah, so you can still do 2.
But it doesn't actually help you to know which scale is real, right? Because.
Yeah.
Yeah. Okay, so if you don't do 1 against 2 again, what if you did 3 against 4?
Did 3 against 4.
Yeah.
With the same scale? Or
Maybe with the other scale.
with a different scale? Then.
I mean, you could do it with the same scale or a different scale. We can try both, yeah? So what if we did
Wait.
3 against 4 with the same scale?
Then
Okay, so what are the possibilities? They could be equal, right?
They could be equal or different.
Okay, what happens if it's equal?
If it's equal, then
Yeah, so Winston, we came up with this thing where, you familiar with the question? Yeah, so
if it's equal, then
if the scale shows that the weights are equal, right, then the weights are actually equal. Okay? And the reason is because no matter which scale it is, if the weights were different, they would show it's different. So if the scales show it's equal, it means they can't be different. You know? Okay, so basically we don't know which scale is which, but no matter which scale we use, if it shows it's equal, then it is equal. Okay? Yeah, so if 3 equals 4 on one of the scales, then 3 actually equals 4. Okay? And because 1 is greater than 2 here, and we know that the fake one has to be here, then this has to be a true result. Yeah?
Yeah.
So then the 1 is the fake one. Yeah?
Yeah.
So if 3 was equal to 4, then we know that 1's fake. Yeah?
But if 3 was different to 4?
Okay, let's say 3 is greater than 4. Okay. What do we know?
And we use the other scale, then...
Yeah, so the problem here is we need one more weighing, right? Because we now know the scale we used is fake. Yeah?
Yeah.
Yeah, we still need to use one more to find it. So we don't know if the fake one is like the 3 or the 1. Yeah?
Yeah.
But the fake one can't be the 2. Yeah?
Yeah.
And it can't be the 4. Yeah?
Yeah. So then we have to measure 1 with 3.
No, you don't have to, yeah? You gotta be careful with your words. So you can do a lot of things to get to the conclusion. Okay? You can basically do whatever you want and you get the answer. Okay?
Yeah, at this point you're really close.
Yeah. Well, the point is, but the question still remains, can you do it in 2 weighings? Okay? Can you have 4 weights with 1 fake figured out in 2 weighings? Okay? So it seems like we can't really figure out in 2 weighings with 1 plus 1, yeah?
Yeah.
Okay, if we change scales to get 3 is greater than 4 on the other scale, what would that mean?
Let me see 2v2. 2v2. If it's a 2v2, then you can narrow it down to 2 of them because.
Okay, so now we're considering.
Have to show the true possibility.
So we're considering 1, 2. So 2v2 now, yeah.
Yeah.
So see, this is actually part of the bigger problem as well. So it's productive to look at small cases. So 1, 2 versus 3, 4. Yeah.
Yeah. In 1, 2 versus 3, 4, they cannot be equal. So whether you're using the real or the fake, it will show the real possibility.
Okay, so
so-
it'll show you the truth, yeah?
Yeah.
So it'll show you 1, 2. Let's just say it shows you 1, 2 is greater than 3, 4, yeah? The other case is symmetrical.
Then you can weigh 1, 2.
Okay, so you should take a step to say, look, this means that the fake one is with 1 and 2, right?
Yeah,
Yeah.
that means it's 1 or
Because
2.
this is a true result, so the heavier thing is here, yeah? Okay. So if the heavier thing is here, then your problem becomes, can I figure out 2 weights with 1 fake in 1 weight, right? So all of these are just special cases of the problem with 13 and 13 adjusted to other numbers, yeah? So I have 2 weights, can I do it in 1 weight? You know? I don't have many choices, do I?
Yes, you can.
Yeah, so I have to weigh 1 against 2, right?
Yeah, and then whichever one's heavier is the heavier one.
Yeah, and it will always show me the fake one is heavier because one of them is definitely fake and the other one's real. So no matter which scale you use, you get the real answer, right?
Yeah.
Okay, and if you get the real answer, then you can use the answer to tell you that the heavier one's fake. Yeah?
Yeah.
Okay, so you can actually do 4 in 2 goes, yeah? Yeah? Yeah.
But I've got 5.
5. Okay, but what about 5? Why not just what about 5?
Okay.
Try not to start sentences with a but. It's not just a matter of grammar. It's a matter of politeness.
Okay.
It's like if you start a sentence with a but, it's like you're disagreeing before you even start with what you're saying. Does that make sense?
Okay.
Where is the Lucas?
So 5, if you use 2b2, and it's in the fake balance, and they're all real, then that won't work.
Okay. In a few minutes, I want to show you a very cool argument for the question from last week. Okay, and then we'll continue with this. And for this week, it'll be cool. We'll see if one of the actual students who did this exam got it right or not. Okay, you can help me judge if the solution is correct or not. Okay, and then if we have time, we can see the official solution for this problem.
I don't think you can get it with 2 weighings for 5. I don't think you can get it with 2 weighings for 5. So,
哦，我是不是忘了是吗？哦，好。
if you weigh 3 but just 2 and it shows you. These are my tricks.
Okay, I want to show you something kind of cool. Do you guys remember the problem from last week? The one I said was the hardest problem in the world
Oh, that one, yeah.
for year 10 students.
Yeah.
So it's this one.
The one at the top here.
Yeah.
Oh.
Okay. Okay, let me just get my screen up.
Wait, is the answer being scrolled?
Yeah.
Oh.
It was also talked about last week, and you probably missed it for some reason.
Pretty sure the answer was
Yeah.
Oh yeah, times 2 minus 3, I'm pretty sure. Alright.
Hello?
Oh, hi Aiden, how are you?
Thank you.
Okay, so okay, let me see if this thing's still working. Close it and open it.
It's just showing a loop.
Okay, so I was saying this is the hardest question in the world for your 10th, right? And I gave you a solution last week. Well, there was actually a little bit of an issue with the solution that I think can be fixed, but you guys didn't quite notice when I showed you, okay? And maybe that's a point that I want to try to make when we're trying to listen to solutions is you can't necessarily assume everything's just going to be okay, right? You have to make sure it's okay. And part of the solution, I don't know if you remember, it was involved showing that one of the bishops couldn't go to the other bishop using only captures, right? So a slight issue with that is that if you keep using it, right, it might not apply because the assumption that they can't move to those squares to make you capture is on the initial position, right, and not necessarily on sort of the messed up position. Does that make sense? Okay, but you can kind of fix that if you're careful. So, but what I want to show you is sort of the elegance of mathematics. Okay, so what are we trying to show? So we're trying to show that if you have a board like this, okay, let's just say it's
rectangle.
let's just say it's 6 by 6, yeah. Yeah. Okay, and let's say we place the bishops on these squares. Yeah. That makes sense?
Yeah.
Okay. So what I want to show you is that no matter which one of these is like the white bishop and which one's the black bishops, okay, there's no way to finish this position off in less than 11 moves. Yeah? That makes sense? Okay. So so pretend this one is like the other colored bishop. Yeah?
Yeah.
Okay. Yeah, so I guess Hillary wasn't here last week for this question, but do you understand the statement of the question? Yeah. So we replace 100 by 6 to make it easier to understand. Okay. So this is a 6 by 6, and then there's 6 bishops. Yeah. Okay. And for 6 by 6, Michelle, stop making noise. Okay. And this is your last chance. For 6 by 6, we're saying that it can't be done in less than 11 moves. Okay. And to show that this is our example of a situation that can't be done in less than 11 moves. Okay? Okay, so watch this argument. This argument is actually very cool, okay? So suppose we know that's a white square, right? Okay?
Yeah.
So let's call this is a diagonal, yeah? That's one diagonal, yeah? Okay? This is another diagonal, yeah?
Yeah.
That makes sense? This is another diagonal,
And so on.
and this is another diagonal, and this is another diagonal, and this is one another diagonal, yeah?
Yeah.
Okay, so these are like the kind of the right left to going from bottom left to top right diagonals, yeah? Right, how many of them are there?
6.
6, yeah? So 6 blue diagonals, yeah? Okay. Now let's count the diagonals going the other way, yeah? How many of them are there?
5. 5 in total.
So there's only 5 green diagonals, yeah?
Yeah.
Alright, so it's 5 green diagonals, yeah? Okay. So how many diagonals altogether?
11.
11 diagonals, yeah? Total. Yeah? Okay. But if you look at the border arrangement, then all 11 diagonals have this very interesting property. And the property is that each diagonal has a bishop on it. Yeah?
Yeah.
You see that? If you look at all the green and blue diagonals, every single diagonal there's at least one bishop on it. Yeah?
Yeah.
That makes sense? Okay. So every single diagonal has at least one bishop on it.
At least you move them.
Oh, we haven't talking about moving, yeah?
Okay.
Okay, but now we're going to talk about moving. So let's consider when we're moving the bishops, okay? So if we make a move, okay, can we? So say there was a bunch of diagonals with bishops on them, yeah.
Yeah.
Obviously, if we make a move, that move affects the diagonals that the bishop is on, yeah. Okay. But can you see, no matter which move you make, the number of diagonals that have a bishop on it can only decrease by 1, at most 1. Does that make sense?
Yeah, because bishops can only move on one diagonal.
So if you have a bishop, okay, and it moves,
Then it has to either
so like
move
here,
on one
yeah,
diagonal or the other diagonal, so therefore it has to stay on one diagonal.
yeah. So the bishop that moved, right, is on at most 2 diagonals, right? Yeah? And it obviously moves onto one of the diagonals. So let's say it moves to this one, right?
Yeah, but it's still on that
So
diagonal.
that diagonal maintains the property of having a bishop on it. Yeah? Because this bishop is still on it.
So
Yeah?
therefore it only
Okay.
decreases by 1.
So the only diagonal that could lose the property of having a bishop on it is the other diagonal, right? Does that make sense?
Mm.
Yeah? So every move can remove at most one diagonal from the number of diagonals that have a bishop on it. Does that make sense?
Yeah.
Okay. And remember, we started with 11 diagonals like that. Yeah?
Yeah.
So if we were to get to 2 diagonals with a bishop on it, we would need at least 9 moves. Right? That makes sense? Because you need at least one move to get rid of one of the diagonals. Yeah? Okay. So right, maybe am I saying the answer's maybe I'm saying the answer's 9, not 11. Okay. So if you have 11 diagonals, okay, at the start, right? And the end, what's the end position? The end position there's only one bishop, right? That's where you want to get to at the end. There's only one bishop left, right? And that one bishop is going to be on 2
The
diagonals.
answer is 9.
Yeah, so here the answer is actually 9, yeah? But can you see how cool the argument is? So the point is, to get from 11 to 2, you need to decrease by 9, right?
Yeah.
But it takes at least one move to decrease by 1, okay? So it will take at least 9 moves to decrease by 9, yeah? So it's impossible to solve this position in less than 9 moves. Does that make sense?
Yeah.
Yeah. Yeah. Yeah, sorry, it should have been 9 because it's meant to be 5 times 2 minus 1. I did 6 times 2 minus 1. So the reason it's 5 times 2 minus 1 is because you need to capture the 5 bishops. Yeah? Okay, but
It should be 6 times 2 minus 3 or 5 times 2
Yeah.
minus 1.
but you can see what happens for the actual example. Like if you have 100 bishops on 100 by 100, yeah? How many diagonals are there?
199.
Yeah, can you see there's 199 diagonals altogether, yeah? So 199 diagonals, okay? And the final position is a one single bishop and there's 2 diagonals, right?
Yeah.
So can you see how many moves you would need at least to get from 199 to 2?
197.
You need at least 197, right? Yeah?
Oh, yeah.
Because you need at least one move for every one. And we need to get 197 of them. Right? Do you see that's a very nice argument? It's very clean, right? Yeah, so that proves that you can't get anything lower than 197. Yeah?
Yeah.
Okay. Do you guys remember why we could do it in 197 no matter what? You guys remember that? So what does 197 really mean, okay? 197 is basically 99 captures, right? Plus 98 moves that are not captures. Yeah? You have to have 99 captures because you have to go in from 100 bishops to 1 bishop, right? Yeah? Okay. But you have 98 moves which are not captures, which means you're allowed to sort of move once and then get captured, okay? For every piece except for one of them, okay? Because you only have 98 instead of 99, okay? And there has to be one piece which is just captured without moving, yeah?
Yeah.
Okay. And you can always do that because if you count the diagonals, right? In one direction there's 100 diagonals, yeah? But in the other direction there's 99 diagonals, right? So if you consider the 99 diagonals, okay? So let's say here there's 99 diagonals, yeah? But you have 100 bishops, right?
Yeah.
So if you have 100 bishops, that means there has to be one of the diagonals has 2 bishops at least, right?
Yeah.
Because there's less diagonals
yeah.
than bishops. Yeah?
Yeah.
Okay. So if there's less diagonals than bishops, then the extra bishop has to go on one of the already occupied diagonals.
Which
Yeah?
means you can take it with the
Yeah.
other one that's on the
So-
other diagonal.
So if you have 2 bishops on the same diagonal, if they're of different colors, then you could just take it on the first move and you've already saved that move from 99 to 98. Yeah? If they're of the same color, it's when one of them gets taken, the other one can just get taken conveniently right after. Right?
Yeah.
Okay? Or if it's taking something else, the other thing can just yeah. So I guess what I'm saying is, so if you have 2 on the same diagonal, one of that move will get saved at some point. Okay? And then for everything else, you're allowed to use 2 moves to capture. Okay? But it's kind of obvious you can take something in 2 moves, right? So every 2 moves you can capture something because, like for example, if I want to use this bishop here to capture this bishop here, right? Well, if there was nothing in the way, I would just go 1, 2 and capture it, right? Okay.
I thought we were supposed to use diagonals.
These are diagonals.
Oh.
I'm only drawing the diagonals now.
Oh, okay.
This is not the chessboard. The bishops aren't the corners of the chess squares either, you know? Okay, so if there's nothing in the way, then you just take 2 moves, 1, 2 to capture it, right? But if there is stuff in the way, like there's another bishop here, well, you could just capture that one instead, right?
Yeah.
And you'd save a move, yeah? But what if it was the same color, you know?
Then
Well,
you can move the same color instead of the other one.
yeah, you can move this one instead of the other one, or you can move the other one to capture this one as well,
Yeah.
right? And then you can capture that one next. Yeah. Okay. So this is very illustrative. Okay, and obviously if there's stuff in the way here, then it's even easier. Okay, because if there's stuff in the way, then you could just use that one to capture. Okay. Okay, there's a few subtle things I didn't mention. I was hoping some of you would point out. Is that, see, the problem is, so what's the problem here? The problem here is I've told you that if you capture it, yeah,
Yeah.
you can just capture the next one right away, right? That was the whole point of having 2 on the same diagonal, yeah?
Yeah.
So that's why, like, if I say I'm going to use this second one to capture that, it might ruin the other strategy, yeah? So that's a problem. So that's why I'll say, okay, I'll still actually capture this way. Okay? That makes sense? Okay. But there's still an issue, okay? Another issue is what happens if, for example, this guy captures this guy, right?
Yeah.
And then he captures this guy right away, yeah?
Yeah.
But what if those 2 are the last ones of their kind, yeah? And there's more of these somewhere else. Then you'd be left with only one colored bishop and you can't finish, right? Yeah?
Yeah.
So that's a problem, right? Do you know how to solve that problem?
Instead you take the other way.
Yeah, okay, Ernest is kind of on a roll here. So instead of taking them both in a row, you can have the last guy take the guy that took the first, so you can have a recapture. Yeah? So like 1 captures 2 and then 3 captures 1. That makes sense? Instead of 1 captures 2 and then 3. Yeah? But the point is, it's still the same number of moves. Yeah? That makes sense? So the strategy is actually pretty basic. It's just capture whenever you can and save a move at least once. Yeah? Okay, and then so it's actually a super short solution to a really hard problem. Okay? And I guess that's why this problem made it into this contest. It's kind of a very beautiful problem. Okay. Alright, so do you guys have any questions? You guys still remember what the answer is? 197, yeah? Yeah, so at the end of the day, like, I guess one thing that's good about this for you guys is, like, there's actually a number, yeah? You can actually understand the answer is 197. It's not like the answer is, like, maybe. The answer is, like, 197, Okay, it's just that you have to prove it's 197. You can't just like guess it's 197. You know?
It's hard to guess the correct answer if it could be anything.
Yeah, but like you wouldn't even know it was right. Yeah, and so I guess part of the thing we're trying to work on in maths is the certainty. Yeah, being sure of it. Okay, would you be able to bet $100 on these 100 bishops? You know, like how sure are you? You know what I mean?
Unless it's like a chance question.
I think you're not really thinking along the lines of what I'm saying. Okay, so no questions about this. Are you good with this?
Yeah.
Yeah. The hardest problem in the world, guys, for year 10 and under. Okay, so my next idea is
What about for year 11 though?
for year 11 and 12 it was like this question, but we're not doing this one today. I don't think we have enough time. Gabriel's gonna leave soon, so I want to at least start this thing before Gabriel leaves. Okay. So what I want to show you is I want to show you the student's attempt at solving this. Okay, and our job is to judge if it's correct or not. Okay, that is our job. Okay, so if we look at this, we have the name blanked out. Well,
What is it called?
it's a bit laggy. Yeah, it's almost 6.
Where is it? On the other.
It's 1 hour early.
No, it's
1 hour early.
It's 1 hour early.
Oh, it's 1 hour early.
Yeah.
So it's 4:50.
No, the time it says is like.
It's 1 hour late.
There's 1 hour
So
early.
What do you mean it's 1 hour late?
Because
The
time
time itself is later than
it's
that clock.
5:50.
Yeah, which makes the clock early and the time late.
It says 4:50. It's 5:50 right now.
Yeah, it's 5:50 right. Okay, let's not waste any time. Okay, Gabriel has to leave soon.
I don't understand.
Okay, you guys remember the problem? Question 5?
Yeah.
Okay, so you guys now, you gotta put on your judging hats. You're on the judging panel for the International Tournament of Towns, and you could decide the winner of this competition. Okay? So the question is, did this person solve it? Okay?
Correctly.
Yeah. Okay.
This guy's in Wellington Senior High School.
Right, this is just showing a bit too much here.
What?
Zaurini in year 9.
What?
At the top, like the file. The part that says file.
It's still works.
Okay.
I bet it's not.
What are you doing?
With hat.
Okay. Tom can determine the fake weight for sure in 3 weighings. Yeah, that's what we're trying to show. Okay? So basically, you just gotta tell us what the weighings are, yeah? So the first one is like, it's really like, I mean, it's 6 versus 6, 4 versus 4, 5 versus 5. It's one of those weighings, right? And then the second one, because there's so few weighings, the second one probably needs to depend on the result of the first one, yeah? And the third one should probably depend on the result of the first 2 weighings, okay? So if you chose the weighings before the first result came out, it's probably going to be wrong, okay? Okay. Okay, well, the weights are A, B, C, D, E, F, G, H, I, J, K, L, M. So notice that there's 13 letters of the alphabet up to M. Yeah, M is halfway. It's 26 letters. Okay.
F is 6.
Okay, and you call the pans P1. Oh wait, the pans are not the same as the balances. Okay, B1 is one of the balances, and B2. Oh, okay, this is not good. This okay. So if you call so B1 specifically refers.
At the top it says conditions, at the bottom it says solution.
Yeah, so B2. Yeah, so this notation is not great because it actively shows that because you don't know which one B1 and B2 are really. So it should just be the balances. But here the B1 stands for the correct balance, yeah?
Yeah.
And B2 stands for the fake balance.
P and P2.
Okay, the pans are P1 and P2. So I don't know if you ever actually need the pans because you have the letters. Okay, when P1 equals B2, B1 shows P1 equals P2. B2 shows P1 equals P2. Or P1 greater than... No. When P1 is less than P2 or P1 is greater than P2, B1 shows that. Okay, so it's a little bit confusing, but they've written like this seems to be like the truth of the weighing, and then they're saying B1 and B2 shows what the balance shows of the weighing. Yeah. Okay, so do you understand their notation?
Yeah.
Okay. Okay. Okay, the first weighing, yeah. Can someone tell me what their first weighing is?
6v6.
Oh, the same as your thing. 6v6, yeah? Okay. 6v6 is a bit of a red flag for me. Just because, well, if you do 6 versus 6, you're kind of in the situation where, like, you know, even if you knew the scale was the right scale, right? 6v6, and it could show you that it's fake plus 5, which is heavier than 6 real ones, right?
Yeah.
In that case, you're stuck with 6 weights. One of them's real, one of them's fake, and you have 2 weighings. Yeah. So it's essentially the problem that we solve, but with 2 more weights.
Wait, what does WLOG mean?
Oh, without loss of generality.
What does that mean?
Yeah, I haven't even finished speaking, so why are you asking the next question? So, without loss of generality just means, like, so, so with, question? Yeah, so it says A plus B plus C plus E is greater than G plus H plus I plus J plus K plus L, right?
Yeah.
Okay. So if you wrote that, then you might think there's another case where the G plus up to L is greater than the A plus up to L. Yeah?
And that's basically
But it's basically the same case because you didn't really know which one was which anyway, right? So it appeared that generality was lost because you didn't consider all the cases, okay? But they're telling you that generality isn't lost because both cases are actually the same. Yeah? Does that make sense? So generality refers to how general your argument is, right? If your argument's general, then it applies to everything. And so if you want to solve the whole problem, you have to consider all the cases, right? And you don't want your argument to appear to be specializing only to some of the cases and forgetting about the others. And so people write log to do that. Okay, A plus B plus C plus D plus E is greater than that. Okay, since if P1 equals P2. Okay, so it's not actually clear what we're logging at the moment. Yeah. So it could be that's the case, but it could be that we don't care about the equals case either, right?
Yeah.
So you kind of have to figure it out, which is a little bit not clear. So like usually when you have case 1, it should be clear what the case. So wait, Tom puts 6 weights on the other side and leaves one out. This gives 2 cases.
It shows.
Yeah, so it's really just 2 cases. Like if they don't tell you what the cases are, you naturally think the 2 cases are they're equal or they're not equal, right?
Yeah.
So then case 1 would be the case where they're not equal, presumably. Okay?
Yeah.
And then it's saying these 6 is heavier than these 6. Yeah?
Yeah.
Okay. Okay, and it's they're not very careful about whether it's shown on the balances or whether the weights are actually like this, which is kind of annoying because they made that distinction at the start. Okay, so since if P1 equals P2 on either of the balances, P1 equals P2 is accurate. What does that mean? Therefore, the weight left over is the fake weight. Okay, let's see what the second case is. The balance shows one pan is heavier than the other. Well, log assume P1 is greater than P2. Yeah, see, this is contradicting their notation. Yeah. So their notation was when P1 is greater than P2, it meant that it actually was greater than P2. But we're getting this confused with what the pans are showing. Okay. Yeah, this is not a good start. So the first case, what is the first case even? The balance shows that the first 6 is heavier than the second 6. Yeah? That's the first case. And
Oh, as in like the first case, if they're equal, then they are equal. Therefore, the weight left over is the false weight.
yeah, so if it showed that they were equal, then they are equal. We went through that before, right?
Yeah.
So the balances showed they were equal. Okay, but this kind of thing would need to be proved. Yeah, they can't just state it like this without proof. The weight left over is the fake weight. The weighing shown from the balance. Yeah, it should be shown, right? The weighing shown from the balance is first 6 is greater than the last 6. Yeah. Yeah, so that's not actually true, right? Like if the weight showing the first 6 is heavier than the last 6, the weight left over isn't necessarily the fake weight. Yeah. Okay. Okay. What if the balance shows something else?来，小人，我送他下来。
OK，他再下来哈。
好好。
好，谢谢。
Alright. Okay, so Gabriel, maybe 20 seconds and you can go, okay? Okay, so try to give you a summary at least. So the second weighing, what's the second weighing? Has weights A, B, C, D, E, F is heavier than P2. Tom need to split the weights in P1 and group them into 3, into B1. Okay, the second weighing seems to be splitting the 6 up. And the third weighing... Oh, what? Where's the third weighing? Yeah, I guess as far as Gabriel is concerned, this is very likely to be wrong. Alright, if you want to see the rest of this, I have it on video, so I can send it to you. Okay. Alright, so yeah, your dad's downstairs.
Bye.
Bye. Good luck in your game.
What do you mean, kids?
Just playing a basketball game.
Oh.
Okay, but you know, saying it's wrong or right, it's kind of like it's not really. Yeah, like we want to be like mathematicians, you know. We want to know why it's right, why it's wrong, you know. Okay. So if we were just like, if we just appreciated maths like we appreciate music, we just listen to the song and we say like it or not like it, right? But if we're musicians, we kind of want to be able to produce it and we want to know why it's good, why it sounds good, you know, that kind of stuff. So maths is it's a bit different from the point of view of the fan and the point of view of a professional. Okay, so yeah, so the first weighing is very unclear what's happening, yeah. But what is clear is it's 6 versus 6, yeah. Okay. I mean, the thing about this is we don't have to just follow what they're doing because we can figure out what 6 versus 6 means for ourselves, yeah. Does that make sense? See, because if you do 6 versus 6, right, and you don't get to choose, like you don't know which balance it is, yeah, then there's really just two conclusions, yeah. It's either equal, yeah, in which case the last one is the fake one, right?
Yeah.
Okay, and then you're done, right? And you're done in one way,
But it's
yeah.
not that easy.
So you can't ever be that lucky. So you can assume they're gonna not be equal, right?
Yeah.
Okay, and if they're not equal, then the problem is you don't know if it's not equal because the scale is bad or because they're actually not equal, right? But chances are they're not equal because they're not actually equal because you have 12 out of the 13 right there, yeah? Okay. So in sort of the best case, okay, it's because you have a fake plus 5 reals, yeah? On one, so you know which, in 6 of them there's 1 fake and 6 reals, yeah? Okay. So we actually know that for this to work, we basically need to be able to solve this case with 5 reals and 1 fake in 2 weighings, right?
Yeah.
And we showed that we could solve four coins with 1 fake in 2 weighings, yeah? But the question is, can we do 6 in 2 weighings? Yeah? Okay. And I'm saying it's probably unlikely, okay, just given, but maybe we could try, yeah? So we have a little bit more time. So do you guys want to try it? Can we try and solve, or at least show it's not possible, yeah? To get, so we had six weights, 6 weights, and one of them's fake, yeah? Yeah. Can we figure out what happens in 2 weighings, yeah? Can we figure out what happens in 2 weighings? So you don't have any much choices. The first weighing has to be like 1 versus 1 or 2 versus 2 or 3 versus 3, right? But then the second weighing is the crucial one. Yeah.
if they're not equal, then you're left with 1 fake and 5 reals. If you do a 3v3, whichever one's heavier is the one that contains the fake, because we know that there's a fake in there.
Okay.
Wait, I forgot there's an extra one.
Okay, so remember this, okay? If you have 3v3, yeah?
Yeah.
As Ernest says, because we know it's a fake in there, it has to show you the real result, no matter which balance you use, yeah? So then what you know is you have 3 of them, and one of them's fake, right? But you only have 1 weighing, yeah? And we showed at the very beginning it's impossible to do that in 1 weighing. Because
The only other thing is
if you have 1 weighing, you might pick the 2 real ones and the fake scale, or you might pick the fake one with the real scale, and you don't know if you got it or not. Yeah, they'll show the same results.
Wait, I forgot something. It's a 66 and there are 13 in total. And if they're all real, the chances are they're not, but if they're all real and it shows that they're not equal, then it could be 6 reals that you're trying to do, but that's still not possible to find it out
Yeah,
in 2 moves.
yeah. So I'm actually here. This is like a better than that case because you actually know, like it's almost like you're given like that the scale is real. Yeah.
Yeah.
So it's actually it's even better than what you would have normally. But even with the extra certainty, you can't resolve it. Yeah.
Therefore, this person got it wrong.
Yeah. So can you see you basically can't do 3 on 3? Yeah. So 3 on 3 can't help you, right? Because 3 on 3 leaves you with the question of 3 things and 1 weighing, which you cannot answer. So you basically have to start with a 1 on 1 or a 2 on 2. Okay? And we basically know you can't start with a 1 on 1 as well. Yeah? So then you basically have to start with a 2 on 2.
Wait,
Hmm.
I definitely didn't.
So what happens in a 2 on 2? Yeah, so if it's 2 on 2 and it's equal, then you're done, right? Because you know the fake one is the one of the other 2. Yeah? So you can assume it shows you like they're not equal. Yeah? So like A, B is greater than C, D. Yeah? But the problem is you don't know if that's a real result or not. Yeah? You don't know if that's showing you that because you have the AB is greater than CD, or if it's showing you that because AB is equal to CD and you got the fake balance.
Wait, if you do a 6v6 and they're not equal,
Yeah.
so. Wait, never mind. No.
Oh, did Winston want a super duper? He never got one. Or Hillary, did you want a super duper?
I got one at school.
You want one?
Did you want at school? How do you want at school?
No, not school. Mrs. Burns.
She was like,
Oh,
This is God's.
Well, you only have 6. Oh, so that's why.
okie dokie. Okay, so fake plus 5 real. So if you do 2 on 2 and you get AB is greater than CD, the problem you don't know. So your information is very little. Yeah. So it could be that they're all equal, and it's you're on a fake scale. Okay. Or you're on the real scale and AB and the fake one is between A and B. Yeah. Okay, so I guess you have one more weighing, EF, to determine the answer. And your one more weighing, I guess, should be you could use the same scale or the different scale. Yeah. So there's only 2 possibilities though. Okay, so either the fake one is with E and F, or the fake one is with A and B. Yeah. Yeah. Okay, so one thing you do know is the fake one's never with the C and D, right? Does that make sense?
Yeah.
Because then it would show that C and D is greater than AB, right? So the fake one's either with E and F or A, B. So how can we try to finish with one more weighing to figure out which one it is?
There is no way to figure out A, B, and to figure out if it's within A, B, or E, F with one way.
Yeah,
You
so
could
like
do it in 2, but not 1.
yeah, so essentially, so can you see the information we have, okay, is essentially equivalent to um it's kind of like we have 4 weights and 1 weight, right? So it's replacing the problem from 13 replaced by 4.
If you can't do 3
Okay.
weights with 1 way, then how are we supposed to do 4 weights with 1?
Yeah, but what's the difference between this and it's not is it exactly the same as just 4 weights and 1 weighing, or is there a difference? Like is there a logical difference?
With 4 weighings, with 4 weights, you can actually do a 2v2, including all of them. But
Yeah, so I guess one thing we do know, um, so it's not quite the same as 4 weights because we do know that if the fake is within A and B, right? Then we know this the sorry, if we know that if the fake weight is within E and F, yeah, then we also know the scale is broken as well, yeah.
oh yeah,
So if we know so basically there's 2 possibilities: E F with a fake, and the scale is broken, right? That we used the first time is broken, or the fake weight is one of the A B, and you don't know anything about the scale, yeah.
yeah.
Okay. So in some sense, you'd only have to worry about the thing being in EF if you have the broken scale. Okay. So if you use the other scale to measure it, you would know it's the real scale in the case that the fake one's in EF. Yeah. And you'd know you don't know anything about the scale if um the real ones if the fake one's in AB. Okay, so it's not identical. It's not identical to having 4 weights determined in 1 weight. Okay, but you have a little bit of information about the scales. Yeah. So you have one more weighing. What are even all the possible things you can do? So you can basically use the first scale or the second scale, right? Those are your choices. And you get to weigh either 1 against 1 or 2 against 2, right? I mean, it seems pretty pointless weighing 2 against 2, you know? Because if you do 2 against 2, you'll know that the fake one is somewhere, but you won't even know which one it is, because there's something else with it, right?
Yeah.
Okay.
Therefore, making if it starts with 6v6, then it cannot be possible.
Okay, well, let's just try one. So if you have EF versus AB, right? And it shows you EF is greater than AB, then that means the fake one, yeah, it doesn't tell you anything.
That means if it starts with 6v6, then
Yeah, because if
You
you have
can't
2 versus 4, the scale tells you the same thing no matter which scale you use. So the information about the scales becomes irrelevant, and then it becomes trying to do 4 with one weight, right?
Yeah.
So that can't help you. So you have to do a 1 versus 1.
Yeah.
You know?
But you can't find out one way.
Yeah, and if you think about it, this is where the log comes in, without loss of generality, right? Because 1 versus 1, like, because E and F are basically symmetric, you don't know, there's no difference between E and F,
Yeah.
and there's no difference between A and B, right? Then if you do 1 versus 1, there's really only like 3 cases. There's E versus A, E versus F, and A versus B, right?
Yeah.
Does that make sense? Okay, so what happens if we weigh E versus A?
E versus A. But if it shows equal, then it could still be an F or B.
Yeah, so if it's equal, you still don't know what's happening, right? Okay, so that means you can't determine it with E versus A. Okay, what about E versus F?
Same thing.
Well, not quite the same, because if they're equal, well, yeah, I guess if they're equal, it's in A or B, right?
Yeah.
Okay. Yeah, so, but what about A versus B?
If they're equal, then it has to be an E or F.
Yeah,
You could just keep on doing it for
right. So you can't do 6 things in 2 ways, yeah?
Yeah.
Okay. Okay, so that's a good little side investigation. Let's continue. Am I drawing? Oh, I'm actually ended up drawing on the paper. That's alright. Okay, weighing 2. We'll log assume P1 has weights A, B, C, D, E, F and is heavier than P2. Tom need to. Okay, so I guess the point is the second weighing depends on the results of the first weighing. So we start with the case of one of the cases of the first weighing, and then they're telling us what the second weighing is. You know? Okay, so what's it say? Tom need to.
I don't think the grammar is that good.
Tom need to. Baptist. Wait, what does that say? You guys read that?
But
Split.
no, it's but.
Split the weights.
Split. Okay. Tom needs to split the weights. Oh, I don't know if you guys ever do English writing, but
But
when you do more and more English writing,
I do English.
thanks, that's good. Okay, so the more English writing, like the older you get, the longer your writing becomes. Okay, and I find it's always good to read it over at least quickly and once before you hand it in. Okay, have you ever had that advice given to you? Have you?
Yeah.
Okay, so like I'm giving you that from personal experience. because I don't know if you've done this. When you first read it, like the stuff you write is like it's completely stupid, right? Like there's typos. There's kind of like a lot more mistakes than you expect there to be. Okay, but once you find them, it actually looks normal again. So like the stuff that's like going through your mind was not necessarily what was on the paper. That's kind of what I'm saying. Okay, and you're kind of seeing it here, right? Okay, so split the weights in P1 and group them in 3. This time he used a different balance. This gives us 2K. So you see what we're doing, right? We're doing ABC versus DEF, okay? So ABC versus DEF, what happens?
Then it would narrow it down to either ABC or DEF.
Yeah, so if they're equal, the balance used in the first weighing was B2, and actually they're equal.
ABC versus DEF.
Yeah. You know what they're saying, right? So they're saying if you get that ABC equals DEF, right?
Yeah.
Then ABC actually equals DEF, right?
Yeah.
So the first weighing must have been false, yeah?
Yeah.
And so the first weighing must have been done on the false scale, yeah?
Yeah.
Okay. And for the scale to show something false, you had to put equal things on either side, right?
Yeah.
And if 6 things are equal to the other 6 things, then they're all 12 of them are real, right?
Yeah.
So then the fake thing is the 13th thing, and you're done, okay? So that's like a nice little argument, okay? Okay, so that's the first case.
But what are the chances that it will end up as the... What are the chances that the last one, which you didn't use yet, is the actual fake one?
Yeah. Yeah, I guess the chance in practice is none, right? Because you just assume it's not that to make the problem, um, harder, right? Okay, so case 2. If the scale shows P1 is greater than P2, so ABC is greater than DEF, yeah? Okay. So we'll log ABC is greater than DEF. So can you see that? Actually, even without reading, you can kind of see what's going on. So like, if it says ABC is greater than DEF, and it shows that ABCDEF is greater than the other 6, yeah? Like, and you've used both balances, one of the balances has to be real, right?
Yeah.
So that means one of the balances has to have detected the fake one, right? So the fake one actually had to be within those 6, yeah? That makes sense? But you don't know if it's actually among the ABC or not, because the ABC versus DEF could have been done on the fake scale. Actually, no, hold on. No, sorry. You do know that, because you know that the fake one is one of the ABCDEF, right? Yes? And if the fake one is there, then any weighing you do on it will be truthful. Right? Yeah? Okay, so then that means the fake one has to be one of the ABCs. Yeah? Okay. Okay. So I think their argument probably reflects this. So the balance used in the first weighing is B1, and that is true, which indicates the balance used in the second weighing is B2, but this doesn't matter since they both give the correct result, therefore A plus B plus C is greater than D plus C plus F. Yeah? The other case is balance used in the first weighing is the false one. Doesn't affect the statement is true. Therefore, in the second weighing,
Balan. Oh, what is that? Balan
is also true. Yeah. So basically, is exactly what I said, right? So without reading it, you can kind of see that the point is the result is ABC is greater than DEF. Okay, and the fake one is in the ABC. Yeah. Okay, but the problem is you don't know what the scales are, right? Okay, and so you basically got yourself into the situation of 3 weights and 1 weight, right? Which we showed is impossible. Yeah.
Ew.
So this is a trap. So now Tom uses third weighing. So the question is, how will they get themselves out of this problem here? So let's see how they get themselves out of this problem, which we're basically saying is not possible. Okay. If one for what? See. Okay, so they underline this 1 twice. Okay. If 1 from above is true, he is going to use the balance he used in the first weighing. But he doesn't. But how do you know that 1 is true? Okay, that's the problem. And weigh A or B, A and B, or A and C, or B and C. The balance will show either P1 equals P2, therefore the weight wasn't weighed is the fake one, or P1 is greater than P2, therefore it's fake one, or P1 less, therefore conclusion. Using this weighing method, Tom can determine weight is fake in 3 ways. Okay, guys. I think that's it. So, can you guys help me evaluate this solution? Is it correct? So the question's out of 9 marks, okay? Maybe if we want to be a bit more concrete, we can try to think of a score out of 9, yeah? What kind of score out of 9 do you think it deserves and why? Any takers? 7.
I'd say 6.
6. 6.
What are we guessing?
The score out of 9 for this question. Answer.
Actually, 5.
Okay, 5, 6, 6, yeah?
Probably like 3, I think.
3?
6.
6. Oh, you just guessed what they guessed.
Yes.
Alright, Aiden, what do you guess?
I'd say 5.
5. Okay, so basically everyone guessed 5, 2 5s, 3 6s, and 1 3, right?
No, I'm 4.
It definitely does not. It does not.
No,
It's
4.
way too low.
4.
Okay, so one thing about, like, I should make it, like, this marking is not the same as school marking. There's a little bit of difference, okay? So school is kind of like, it's very strange in that school tries to give you as many marks as possible, okay? So, like, there's, like, for example, if you get the first thing wrong and you get the next thing right, you still get a mark, right? Yeah? Whereas in this kind of thing, it's much harder to get marks, you see. You basically get marks for solving the problem. Yeah? Okay. So the fact, like, for example, if you do 6 verse 6, okay, and it's wrong, right? You don't usually get any marks for the things after 6 verse 6. Whereas in school, if you do 6 verse 6 is wrong, you might get marks for stuff after that's of like, you know, like similar to the stuff that would have been if it was like the right thing that came first. Okay. But what's universal, I think, is every time you say something that's wrong, you'll lose a mark. Does that make sense? So like, yeah, so stuff like, I don't know. Like this is something that's common in all maths. It's like, so we have two cases, yeah, right? But the weighing in the weighing of weighing two only seems to depend on one of the cases, but not both. Mhm. And yeah, so you might be shocked to know that this person might get like a one or a zero. Yeah. So this is not like a yeah. So this is not like a how would you say? It's not like a friendly mock trick or treating exercise. Yeah.
Can I get negative?
Huh?
Can I get
Oh, you can't get
How are
negative.
you supposed to get negative?
You can't get negative marks.
-1 marks in total?
I guess for
-1 marks for
See,
deleting the question.
so if you think about it, like saying 6 versus 6, it could be like it could be worth no marks or it could be minus marks. Yeah, because you know 6 versus 6 is not going to work. Okay. Well, at least like not yeah. So and then, but then stuff like if the weighing shows it's equal, then the weights are actually equal. That kind of thing, right? That's worth a mark. You understand? And the reason in this context it's worth a mark is because that's going to be used in the actual solution as well. Yeah? The correct solution will have to use that as well. Does that make sense? So, I guess practically the parts of this which is common to a correct solution are the parts that are going to get marks. Yeah? And it's very difficult to get marks in these kind of competitions. Yeah, so to get 6 out of 9, you basically have to be completely correct with like 3 false statements somewhere along the way. You know what I mean? Like to get 6 out of 9, you'd have to basically have the right weighings. Yeah? But maybe you make one silly mistake in each weighing. Like you forget a case. Yeah? So if you forget like 2 cases, you might get 6 out of 9. Yeah? But here none of the weighings are correct. Yeah? Does that make sense?
That's a good thing.
Yeah.
It might be more
And even if it was correct, like it wasn't shown to work in the end. Yeah?
How can I get 3 rainbow?
Huh? Where's even the third weighing?
And they also missed the third way.
Wait, go down.
This is definitely negative. He deleted the third way.
From there.
Yeah, he didn't even have the way. He
Yeah.
deleted the third way.
Does he believe you can do it in 2 ways?
Where's the third weighing?
Does he believe that you can do that?
No. Look, it says if this is the case, then the balance. So the third weighing is using the balance in the first weighing and weighing A and B, or A and C, or B and C. The balance will show either they're equal. Okay, if they're equal, we know what happens, right? But if it shows P1 is greater than P2, okay. Wait, does this? Yeah, so the problem is this conclusion happens without you knowing which way. You get this without knowing which balance is which, right? Yeah? And the final thing assumes you have the correct balance. Yeah? Okay, and that's something you're not allowed to assume. Yeah? Yeah, so it's basically it's very simple because there's so many mistakes that even if they were gonna get some marks here and there, they'd lose them for the mistakes. That makes sense? Yeah. So it's to say that like if 1, it doesn't make any sense because you don't know it's 1. Yeah? Because both 1 is 1 and which is 2. So then you can't base your weighing on that it's 1. Yeah? You know what I'm talking about?
Yeah.
Okay. You guys have very quick minds for your age, okay? Because if I was the one listening, I would probably not know what I'm talking about, okay? But yeah, but I'm lucky because I don't need to know. I don't need to listen to myself talk. The idea started in my mind.
You don't know what you're talking about. So.
Yeah. Oh no, I do know what I'm talking about. I don't have to hear myself talk and understand it. You know?
What did you get from HSC?
99.95.
You got 90.
The maximum.
I don't know why.
Wait, is that the maximum?
Yeah, the maximum ATAR. You know what ATAR is, right?
Is it possible to get 100% HSC?
Not in ATAR. It's not percent. It's like
Mark.
it's called what's it? Australian Tertiary
Australian
Admissions Rank or something.
And
Yeah, so the highest ATAR you can get is 9.
So you got all correct?
No. The ATAR.
Oh, it's like
No, the so the ATAR is not a measure of how correct you got the questions. It's a
how
rank.
better.
It's a rank of all the students.
Oh,
Yeah.
so you got the top rank?
So I pretty much okay on Maths Extension 1. I pretty much lost at most 1 mark in the whole, all the tests I did. Yeah, all together, 1 mark. Yeah.
Yeah.
Maths Extension 2, I probably lost like 5 marks altogether. Yeah.
Oh no.
Yeah, Maths
Yeah.
Extension 2 is higher than 1.
Like
It's 5 marks.
English, I think I lost maybe like
10 for extension.
10 or 15 marks
Oh no.
altogether. Yeah.
Oh,
Chemistry, I lost like
It's better than
7 marks altogether.
How can you calculate all of this without knowing?
Huh?
How can you calculate all of this?
What with the marks I lost?
Yes, yeah.
Oh, they tell you some of your marks, but then I also have a feeling as well.
This
like-
is like 10 years ago.
Yeah, this was like more than 10 years ago.
15 years ago.
Yeah, okay, let's say 15 years to be nice.
Wait, so at that
You're
time
just trying
Michael
to
wasn't
know
born?
that, you're just trying to tell us. You're just trying to convince us that you know your things a long time ago. Why are you talking
Yeah.
about year thingies?
I mean, I took it pretty seriously back then, so it's easier to remember the stuff, you know what I mean? It's
What's
not like
going on? What are you talking about?
talking about high school.
Yeah, that's Jesus. High school. But no one hears it.
Yeah. Actually, I did better in English than I did in chemistry, which is weird. And then I got a state rank for physics.
Wait, is chemistry a part of math?
Huh?
Is chemistry a part
No.
of science?
No, but they
Yeah.
it uses
Yeah.
maths.
Geology.
It uses maths, but it's like...
Wait, so somehow it's
You
math
got
better than
science.
English than chemistry.
Yeah, so chemistry was because in HSC you do like the school test, and then you do the common test to everyone in the state does. Yeah. So in that final test, I did the worst in chemistry. So and then I did kind of okay in the other subjects. Yeah. Yeah, what does it mean to do bad in something? It's kind of like,
It means you get a bad score.
well,
Compared to the
in
others.
relatively, it's more like, because I ranked first in chemistry in my school, but then I didn't come first in the actual exam. So that's bad. That's bad because the person who did better than me in the test probably still got a lower mark than me, which is not really fair. But something like that happened to me for maths, so then it kind of evened up. Does that make sense?
Yeah.
Okay.
It's hard to explain. I'll explain more when you're doing high school, at least.
The science part, you get one mark and you get
No.
99.95.
Science is only hard in the sense that they make it very vague. Yeah, which is not what the difficulty is meant to be. Yeah. So the difficulty in science is meant to come from the difficulty in maths, because science, the theory of science is founded on maths, right? And but the problem is they found the people couldn't do maths, so they kind of removed all the maths from the science, and so then it became really hard to understand what people are talking about because it was less objective.
Isn't biology part of science?
Yeah.
Isn't like biology study of like human body?
Yeah, so the biology is like a huge subject, but I don't know, like even just one of the major things in biology, and I'm not sure if they teach this in high school biology, but they definitely have to cover some of it, is DNA. Have you heard of DNA?
Oh, DNA.
DNA, right?
What's a DNA?
The DNA is kind of like,
There's something in my body. Never.
yeah, it's a deoxyribonucleic acid or something. But like the point is, the point is, wait, is that what DNA stands for? Anyway, so the point is, like all of like the creatures, right? They have like a DNA sequence that kind of determines how the creature grows, right? And that our DNA is not even that different from the other animals, right? And recently, I mean not recently, but like recently, it's become much more obvious that mathematicians and biologists work together to figure out DNA sequences and stuff like that because it's really like the DNA sequence has what like four. It's like AGNC. There's like 4 proteins or something, and it just depends on what order they come in. So it's like a maths question. So it's like what order the GNACs come in is it determines what kind of creature comes out, and then they're trying to figure out how the different orders make a difference. Yeah, that's a very simplistic way to put it. Okay, but there's lots of very interesting things.
I lost track of why we talking about this.
Why are we talking about this?
Yeah.
Yeah.
Did Hillary asked how you got what you got on HSC?
And then we kind of started talking about science, and then biology, and then
Biology.
DNA. But then see, I tried to bring it back to maths, so then that's why I said DNA, and then back to maths again.
I'm going to high school next year.
Huh?
I'm going to high school.
Yeah, she's
Yeah.
in 6.
Geology.
I'm
Going to
kind of the most boring year.
Which high school are you doing?
You somewhere very far away.
I bet it starts with N and ends in G.
Yeah, but this,
Wait, no, the 3 letters
that's like a
are
really bad version of
yeah.
year 6. It starts with
Yeah.
C. It's like the hotels are worse than this one. No, that
Yeah.
hotels?
Okay, there's one more thing, guys. There's one more thing I want to do before this ends. Okay, I want you to show you something.
Okay.
Yeah. Okay. Yeah. So I will give this. This will get 0. Okay. So
Hey, I didn't give it. I didn't give it 0.
Huh?
I just make kind of say 0.1.
Oh yeah, I can give 1 or something. But the point is like it's basically 0. Yeah. So in maths like Olympiad marking, you don't give points for effort. You only get points for progress. Okay. Okay, there's something very interesting I want to show you. And I'm not sure we have enough time, but we'll try, okay?
It's already over time.
Yeah, so let's try it. Just
Wow.
cooperate, okay?
What is the index 7?
Okay, so I just want to quickly look at the official solutions for this. Okay. So if we look at the official solutions, you might notice that it's in Russian. Yes. Oh, I'm fast becoming a fan of Hillary. Very good. How do you know it was Russian?
I don't know. It looks Russian.
It looks Russian. That's
I know.
you have an instinct for
It's
Russian.
It is
No,
Russian.
because I remember you told me that these questions were from Russia.
Oh, okay. See, that's using your brain. Very good.
I am Russian.
Because I asked why are they
I am
questions
Russian.
about
I think
Oh.
I know it's Russian because I have a chest thingy that is
talking about Russian and this one.
Oh, yes.
Yeah. One time someone spoke Russian in in so
Alright, so actually, well, you might be interested. Like, you know what a PhD is?
a PhD is
Yeah, if you do a PhD in maths, okay, or in like in a lot of subjects, we gotta focus. We have like 10 minutes, okay. You do a PhD. One of the tests that you have to do in a PhD is a language test, okay. I did mine in French, but not Russian. But like the point is, it's a little bit dated nowadays because you have like Google Translate and stuff. One of the tests was you have to read it in another language, yeah. And if you read the whole thing and you translate it, then you pass the test, yeah. You can imagine that used to be very difficult, right? Because like you might have a dictionary. That's all you have, right? You just look up the words. But now like you can kind of just copy it into Google.
But he got the PhD for maths. That's why he's
Yeah.
but I didn't get like a PhD.
You're not even old enough.
I don't think there's an age limit. I don't know.
Wait, there's no age
I am
limit?
now Dr. Michael.
But you haven't got your PhD yet.
I'm gonna go get it. Live streaming.
Yes.
No way. YouTube Studios. We have to
Right, Google.
How did I say hello? Oh wait.
Translate, okay?
Yes!
Alright, I think it's not gonna work straight away because it's gonna exceed the 3,900
Google
characters.
Bro, you just copy and paste it. Copy and paste it.
But we can do it a bit at a time.
3,900 word limit. There's 3,900 reelers always put equal weights on the scales. Note that then a weight that ends up on a light cup is obviously false. And in case of equality, on any from balls, let's denote the weights by X and Y.
Okay, it's not completely understandable, but you know what they like. If you know about the problem, you know what they're trying to say, right?
So what's about the mini words down there?
So n equals and?
Maybe that's
I mean,
like how
backwards
you'd say it in Russian. Решение будем классно вышел. Поровну заметим, что кто так-то живет.
My opinion.
Yeah.
Look at basketball.
No.
Okay, so
I am Russian.
alright, Michelle.
Stop
Thanks.
doing that.
Russian detective.
Okay, so basically they're saying like if you have a weight that's like greater than the other one, the lighter one cannot be
Oh, look at that fallen over.
the lighter weight cannot have the fake coin, yeah?
What's the about 10,710 million results?
The fallen over E.
397?
Oh, I searched for translate.
Every time someone searches translate, that's how fast someone.
That's how many results came up, and that's how long it took for them Google to find it. Yeah, actually, how the Google search works is actually pretty amazing as well.
It's too slow.
Yeah,
Just
For me,
imagine
for
it.
some
Just
reason-
having a method to search quickly across the internet was enough to build like one of the biggest companies of all time.
Why not?
Yeah.
Why is it not instant?
It's kind of crazy, right?
Why is it not instant?
And the way they search it is actually kind of silly if
For
you
me,
think
on
about
the
it.
computer, when I search something on Google, it shows up the answer in Yahoo.
The original yeah. So the original algorithm was just basically preparation. It was just kind of going to all the websites ahead of time to see what was out there. So then when someone searched for it, they could just readily give it to you.
What if we search for
Okay, that's such an obvious thing, right? But that was basically how it was at the start.
10 times? I'm going to go through the one 10 minutes. Russians with the Russia.
Okay.
X and Y. X and Y.
This so.
Okay, so that's just setting it up. So obviously we wouldn't weigh like 2 against 3. We'd only weigh equal numbers versus equal
You're
numbers.
cheating. You're not meant to do this.
Copy and paste and translate and solution the key.
Press slash to jump to the next box.
Alright, hold on.
Oh no.
No.
It's deleting Google.
Italy.
I need to
You just
delete.
copy and paste it again.
But I don't need to start this time. I wanna...
Go meet. Can't you just go to a word pattern and just find out how much is 3,900 words? Okay, I'll be quiet. My unit is quiet, everyone.
Alright. Okay. Let's denote the scales X and Y. By first weighing, let's put 4.
One Libra.
Okay, so they're saying like they're putting. Let's put 4 on the scales X. Oh, shh. Be quiet.
Can I sit there?
Wait, so it either means 4 verse 4 or 2 verse 2, okay? It's not that clear. Libra is in balance. Wow, this kind of translate didn't work.
What's Libra?
That's what I mean.
Scales. Libra means scale.
Then one of the 5 unweighted weights is false.
Second, by weighing we place this. Why is one of the Russian letters look like this?
Second, by weighing we place 2 suspicious weights on the scales X. In equilibrium, false unweighted weight A. Otherwise, either weight A is false if the scales X are incorrect or one of weights BC on the heavy ball.
It's like a spider thing.
Okay, what does that even mean?
There's a fallen over E.
Why is the R
Okay.
backwards?
Okay, so we get let the scales be X and Y, yeah? We get that.
The E is normal. The E is normal.
No, fallen over.
The first weighing will place 4
Like this.
on the scales X.
There's also this E. And there's also a B that looks like this.
Yeah, I think it's 4 verse 4, yeah? Because if you have 4 verse 4, then there's 5 left over, right? So that's why there's 5 unweighted weights, yeah? So we figured that out. Be quiet. Stop making noise.
Exactly.
Okay, so we understand that now. Okay, see how it's like this is kind of like a maths problem, right? You just understand it one piece at a time. You know what I mean? Like the translation. Kind of everything works very similarly. Okay, so if it's in balance, then all of them are equal, right? So 8 of them are all real, yeah?
Yeah.
Then one of the 5 ones that you left out must be the fake one, right? So it really makes sense now that you get that first bit, yeah? Okay, second, by weighing, we place the 2 suspicious weights on the scales X. Okay, what does that even mean?
On just one of the scales.
So the second weighing, yeah?
Yeah.
We place 2 suspicious weights on the scales X. But which ones are suspicious? So, I guess we placed out of the 5, yeah.
What are they doing?
What
And
are
out
they
of
doing?
out of the 5, okay, we either do 2 verse 2 or 1 verse 1, yeah.
Yeah.
Okay. Okay, it looks like it's gonna be 2 verse 2 because it has a false unweighted A, right? It suggests only one thing is not being weighed, yeah. Okay. So otherwise, either A is false if the scales are incorrect, or one of the weights B and C on heavy ball. Okay, maybe it's time to add more. Let's add more. Okay, but our time's almost up. Okay, so we're trying to finish
How
at
come
least.
Russian takes up more space than English?
Because it's a 3,900 limit. That's also that. The text name is text exceeds 3,900 words. You remember that? Why do you think I wrote that?
Oh, it says it right there. It says it right there.
You have too much words, excuse me.
Who typed this? I
Press
bet
Control X.
like this feels
Alright.
Second, by way when you place 2 suspicious words.
Good Tom.
And equilibrium. Both unweighted words. Excellent.
At equilibrium,
Both unweighted
false
weights.
unweighted weight A. Oh,
Otherwise, item.
yeah.
Otherwise, weight A is false. Otherwise, either weight A is false if the scale X are incorrect.
Sorry, incorrect. Wait. See, what the is false.
Does that make sense? Yeah, so even like you don't know which if it's the scales that are problematic or but no matter what, if the heavier the lighter side can't have the fake things, yeah. So it has to be the heavier things, B or C, if the scales are yeah, and or if the scales are false, A is the one that's still the fake weight. Okay, so that actually makes a lot of sense. Okay, by the third weighing, we compare B with C on the scales Y. By the third weighing, we compare B with C. Yeah, so what do we do on the third weighing? We take the heavier ones, right, and weigh them against each other, yeah? On the other scale, yeah? If the scales are in equilibrium, then obviously equal, right? So then A must be the false weight, yeah? Okay, so notice we have 3 left, yeah? And 1 weighing. Okay. Otherwise, if it's heavier, so okay. Alright.
Whose mom is that?
Winston.
Oh yeah.
我送他下来吗？
701.
Seven.
我也送他下来啊。我也下来吗？那个我老婆下去。
No.
哎，你见他们2个人吗？对。Yeah, can we just finish quickly this one case? So can thanks.
我先下去是吧？
你可以先下去见他吗？但是Hillary, wait, do you want to see the last case? Why that works? So if you compare B and C on the scale Y, right? Okay, obviously if they're equal, we know A is the false one. Yeah. But if B is heavier than C, yeah, what happens? Yeah. So if B is heavier than C, right? So otherwise, okay. So one thing is if B is heavier than C, then you know C can't be the fake one, right? So the fake one has to be B or A. Yeah. Okay. So what happens? If A was false, the scales Y would show that they were equal. Yeah. Right, because if A was false, B and C would be equal.
No, my mom's at work.
Oh, so who's picking you up?
My dad.
Why is your dad
Okay, so yeah, maybe you can meet them down there. But basically, it's saying that if B is heavy, if B looks heavier than C on the scale Y, right, then the conclusion is that B is the fake weight. Okay, and they're saying the reason is because so if A was actually the fake weight, then Y would show that B and C were equal.
What's this, Michael?
Just the way, this way.
Michael.
Yeah, see, okay, that's clever because it's saying it's A is only false if the scales X are incorrect. Yeah? Does that make sense? Because it said BC is greater than something other two, right? And so if the BC is greater than the other two and the A was false, then the scale must be also false. Does that make sense? Because if A was false, then B, C would equal the other two, right? And so if A was false, then that means the scale Y must be correct, right? And if the scale Y is correct, it would show B equals C, right? So for the scale to show that B was greater than C, then A couldn't be false. So that's kind of the clever part of it, yeah? So then you know something about the scale as well. So then A can't be false, then B greater than C must mean B is false. That makes sense? Alright, that's it. Alright guys, that's it. Aiden, that's it. Have a good week.
Alright, thank you.
Alright, bye.
See you.
Where are you going? I need where my other keys. When did Dad come? What? I need to knock it off. Yeah, but what if he finished?